Hello, everyone. Mr. Minnick's my name. Math is my game. This morning, I'm joined by my first period Algebra 2 class. A couple of them are excited to be here. The rest of them haven't realized that it's about time to get into some math stuff. So let's just get right to it. Simplifying radicals. A real easy way to think of it is this: factoring out. Factoring out. So you're going to be having to find factors of something. So it's factoring out the square root. So not only are you going to have to know how to factor, not only are you going to have to find factors of a number, but you're going to have to know what perfect squares are and their square roots. So simplifying radicals should really be renamed factoring out the square root of the perfect square factor, of the perfect square factor. It's probably redundant to say factor twice there. Factoring out the square root of the perfect square factor. But if I had to summarize simplifying radicals in one phrase, that's it. That's the golden statement. That's really all you're doing. Factoring out the square root of the perfect square factor. There's a little bit more to it than just that, but that explains the whole process. Factoring out the square root of the perfect square factor. Okay? So what I mean by that is you're going to be asked to simplify something that looks like this. Simplify the square root of the number 40. It's a nice number. It's an even number. It's a multiple of 10. And notice I said it's factoring out. So you need to find 40's factors. Okay? Incidentally, the number 40, the number under the square root, has a special name. If you want to know what it is, it's called the radicand. So if you ever hear me talk about the radicand, which I will in a couple sections down the road, the radicand is simply that number under the square root, in this case, 40. Okay? So what I'm about to do is I'm about to find the radicand's factors. Of course, 40 is 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Now, of those pairs of factors, there's one pair that I love. And I know love is a very unusual word to talk about numbers with. But there's one pair of those factors that I love. And it's this pair right here. Not because they're both even numbers. Not because 10 indicates a decade of years. But because, anybody know why I love it? Yeah. Because there's a perfect square in there. Remember, we said we're factoring out the square root of the perfect square factor. So the deal is there's a perfect square in there, and that perfect square is 4. Okay? So the magic behind this, it's driven by this property that we often overlook. This property says if you have the square root of the product of some things, that you can split up those things into individual products. That's called the product property. And it's really kind of the magic behind what happens when you go from the square root of 40 to what the answer is. So I happen to have my TI Inspire CAS, and I'm going to use it to show you what the answer is. The square root of 40, according to the TI Inspire CAS, is 2 times the square root of 10. Unfortunately for you, the regular TI Inspire will not do these. And I know that almost everybody on the planet Earth nowadays knows about Mathway. And I'm not saying Mathway's bad, but I am saying you should be aware of how to do these types of problems without Mathway, without having to use some kind of computer algebra system. So let's see how we can get to that 2 times the square root of 10. So we're going to rewrite the square root of 40 as the square root of something times something. As the square root of what times what? 4 times 10. And then by the product property, we take that product of things. By the product property, we're going to take this, and we're going to separate them. So by the product property, then we get the square root of 4 times the square root of 10. And I hope that everybody knows what the square root of 4 is. 2. And that's how we end up getting our final answer on that. Okay? All we did was we found the factors of the radicand, 4 and 10. The square root, notice the square root of, let me see if I can get my highlighter going on here. The square root of the perfect square factor. I wanted the blue highlighter. I don't know why it showed up yellow. The square root of the perfect square factor is that 2. And notice that it got factored out. It came out from under the radicand. The other factor remains in the radicand. Does this idea make a little bit of sense, I hope? Good. So let's look at several more examples. Let's try to simplify the square root of 45. So again, you have to be able to find factors of numbers to do this. 45's factors, 1 and 45. 3 and 15. I think that's it. Right? Or are there more? Oh, 5 and 9. Okay. So which pair of those do I love? The 5 and 9. So do we think we know what the final answer is going to look like on this then? Remember what we said, the square root of the perfect square factor, the square root of the perfect square factor gets factored out. So what do we got? It's going to be 3 times the square root of 5. So this is our perfect square factor, and its square root is 3. So a 3 is factored out, and what remains? The other factor remains. Pretty easy, huh? The number one mistake that people make is they get it twisted. And if you get it twisted, it is wrong. What I mean by that is if we look at the decimal equivalents, the square root of 45, sorry, my smart board and my Inspire aren't playing so well together now. So if we look at the square root of 45, of course this Inspire CAS is going to tell me what the answer is. The square root of 45 is 3 rad 5. We did that. Now, if you take 3 times the square root of 5 and you get the decimal equivalent, 3 times the square root of 5 and you get the decimal equivalent, it's 6.7 approximately. If you take the square root of 45, I said if you take the square root of 45, you get the same decimal. Okay? So this is how you could use the calculator to check to see if you're right. The calculator might not give you the right answer, but you can check decimal equivalents to see if you're right. Does that make sense? Good. So a lot of people will get it twisted. They'll say, well, 5 times the square root of 3. That's right, isn't it? Well, is it? No, it's not even close. Okay, a couple more. Let's try the square root of, I love this one. This is the best one ever. It's the best one ever because it's got a boatload of factors. And sometimes people overlook something. There's 1 in 72, 3 in 24, 4 and 18. Why not 4 and 18? Why can't I use 4 and 18? Can't I say that 4's square root is 2, so it's 2 times the square root of 18? There's a problem with this, and the problem is that when I get this far, 18 needs to be broken down further because 18 has factors of 2 and 9, right? So the square root of 18 would be 3 times the square root of 2, and then this 2 that's up here is still down here. And so 2 times 3 is 6, and that should be 6 times the square root of 2. And if I had picked 2 and 36 right from the onset, I would have got there a lot faster. Yeah, so the deal is you want to pick the pair of factors that has the biggest, the largest perfect square. Does that make sense? Okay. Last set here. Square root of 200. Square root of 300. Square root of 500. Love these ones. Square root of 200. So that's going to be 1 and 200, 2 and 100. Isn't 100 a really big perfect square? So what's square root of 200 going to be? 10 square root 2. What about square root 300? Wouldn't the square root of 300 be 1 and 300, 2 and 150, 3 and 100? So the square root of 300 would be 10 square root 3. Can we figure it out? What's the square root of 500? 10 square root 5. Last one, I promise. What about the square root of 900? Is it 10 rad 9? No, not in simplest form, because rad 9 is 3, so it's no, not 10 rad 3. How about 10 times the square root of 9, which is 3, which it would be 30, because 900 is a perfect square. Remember, I asked you to memorize your perfect squares up through 400. There's a lot more beyond that. Keep in mind. Okay. So, any last minute questions? Shout outs? I'd like to give a shout out to anybody watching this back at home. I'd also like to give a shout out to the future Mr. Minnick for being such an awesome guy. It's been real. It's been fun. See you next time. Have a great day.